Hello, Mr. L's biology students. I'm with you today to work on the spontaneous method worksheet. Rather than have you do this in class and then us go over it, I thought it would be more useful for me to walk through it in a screencast, filling out my ideas so then you could fill out your own copy. This can then serve as both your example of how to find the parts of an experiment and notes on the scientific method that will be very helpful for future quizzes and the next group activity when I assign your group to work on some scientific method practice problems and then present them on a whiteboard to the rest of the class. This particular example in this worksheet is going to look very familiar. It's the Reddy maggot experiment that we've talked about a few weeks ago, but I think it is a great example and I want to work through it one more time. So let's begin. It says, long ago, many people believed that living things could come from non-living things. They thought that worms came from wood and that maggots came from decaying meat. This idea was called spontaneous generation. In 1668, an Italian biologist, Francesco Reddy, did experiments to prove that maggots did not come from meat. One of his experiments is shown below. So we have here, clearly, two different groups called Group 1 and Group 2. You can spot already some similarities and some differences, I hope. That's going to become important when we get to a later question. We're told Reddy placed pieces of meat in several jars. He divided the jars into two groups. He covered the first group of jars with fine cloth. He left the second group of jars uncovered. Reddy observed the jars for 7 days. He saw flies on the cloth of the covered jars, and he saw flies laying eggs on the meat in the uncovered jars. Maggots appeared only on the meat in the group of jars that were left uncovered. Let's answer these questions, and we're told that there are some on the back as well. First of all, we're told what was the problem Reddy was trying to solve. List as a question. And if you'll permit me, I think I'm going to highlight that word question because we often do state scientific problems in the form of a question. It's often easier to put it that way. It doesn't have to, but I like doing it that way. So now that I had a chance to... All right, I'm back. I do apologize for the quick pause there. I had to change a couple of my settings. So it is question number 1. What was the problem that Reddy was trying to solve? Let's put it as a question. And I think we can make the question, are maggots spontaneously generated from meat? Hope you don't mind my typing rather than writing. I just kind of thought my typing is a lot easier to read than my handwriting, as you've seen me write on the board. So I thought this would be easier to follow. So the problem, I think it's fair to say, he wants to know, are maggots spontaneously generated from meat? Do they come from the meat? So next up then, switch back to my highlighter here. What was Reddy's hypothesis? And a hypothesis is just a prediction. And there's a couple different ways that you can write a prediction. But in biology class, my preference is always to do it as an if-then statement. An if-then statement. And let's put that into red. Okay, so if this happens, then I expect that to happen. I like writing my predictions that way, and I'm going to do that for Reddy's experiment right now. So let me make sure that I have got the color that I want, and I do. Reddy's hypothesis: if jars of meat are covered with cloth, then no maggots will appear on the meat. That seems like a pretty reasonable prediction to me. I think that's what Reddy was expecting when he set this one up back in the 1600s, that if he keeps some of his jars of meat covered, those jars will never show maggots. So let's go with that prediction. Could you have done it the opposite way, that you predict that the uncovered jars are the only ones that will have maggots? Sure, that's an equally valid prediction. So if you would then flip it over to the back page, and I should be able to scroll down here, and I can. How did Reddy test his experiment? Explain the environmental setup. Well, remember, if I scroll back up real quickly, that there were the two groups, the group 1 of covered jars, the group 2 of uncovered jars. So I'm going to describe them that way for question number 3. So there was group number 1. And I'm going to call group number 1 our test group. And let me, just to be consistent, let's put that in red. So group number 1 is the test group. Why do we call them the test group? Well, there are 4 jars in that group containing meat, and each jar is covered with fine cloth. I call this the test group because normally the jars would not have been covered with cloth. That was something Reddy had to choose to do. So that was what he was testing. It was his test group. So then what about group 2? Well, we would call that the control group. And I'll talk more about that when we get down to, I believe it's question 7. But I think it's enough to say that the control group also had 4 jars containing meat. And in this case, each jar was uncovered. That's a pretty brief explanation of his setup, but I think you'd agree that there's not much more than that shown in the picture or described in the experiment. A test group, jars with meat covered with cloth. Control group, jars with meat uncovered. Let's move on, if we can, then, to question 4. Manipulated variable and responding variable. Before I get into the finer points of those variables, I think it's worthwhile to remind ourselves that another name for a manipulated variable is the independent variable. I think I'd like to change the color on that one. Maybe change that to a nice purple. So our manipulated or independent variable. Well, let's remind ourselves first of all what that term means. If you've got a manipulated or an independent variable, it is what the experimenter decides to change. It's what the experimenter has chosen to change, chosen to test. And in this case, Reddy definitely decided that he wanted to have 2 groups of jars, and that his 2 groups of jars should have a different type of covering. So we can say that type of jar covering, which in this case was either cloth or no covering, that was pretty definitely his manipulated variable. It's what he decided to make different. All right. From there we go to question number 5, the responding variable. And it's probably worth reminding ourselves that a responding variable, another name for that, is the dependent variable. And let's see, I put the independent in purple. Why don't I do the same for the dependent? Just 2 different names for the same kind of variable. The responding variable is what the experimenter measures or observes. what the experimenter measures or observes. And we can color that in red. And then come back over here. Because Reddy's dependent variable, his responding variable, was simply the appearance of maggots on the meat. Either he observed that there were maggots on the meat or he didn't. It was very straightforward kind of variable. They were either there or they weren't there. So manipulated and responding are variables we've talked about a couple times before, especially in bell ringers. Number 6, I think, is new, though. I don't think we've ever talked yet about what a controlled variable is. And a controlled variable is, there we go. Controlled variable is what the experimenter must keep the same for all groups. Yeah, no, I didn't want that capitalized. What the experimenter must keep the same for all groups. And let's color that in red. So then if I slide back over here, it says to list at least 4 controlled variables for this experiment. 4 things the experimenter, Reddy in this case, made sure to keep the same for both groups of jars. Okay, I think I'll just go ahead and, should I letter them? Should I go A, B, C, D? Let's do that. So A, and I want to keep that as red. He said, or I'm sure he decided, to use the same type of jar for both groups. B, I think he decided to use the same kind of meat in every jar. It looks that way in the picture, certainly. C, it does not explicitly say this in the description, but I'll explain in a second why I think this has to be true. Same location for every jar. What do I mean by same location? I think to have a fair experiment, Reddy would have had to take both groups of jars and put them in the same place. Outside his back door, on his windowsill, in his kitchen, in his attic, wherever he decided to do that. I'm not sure exactly where he put them. But a fair experiment, he would have needed to put them in the same place. For instance, he could not take one group of jars and, say, stick them in the refrigerator. I don't think they had refrigerators in 1668, but you know what I mean. Couldn't take one group of jars, stick them in the refrigerator, and then put the other one outside. Or leave one group outside and put another one underwater. That would totally be introducing a new manipulated variable when we're only supposed to have the one. The one thing he got to decide was the type of covering. Location then should be the same. Likewise, and this is stated directly in the description, he had the same amount of observation time for both groups. I believe it said he observed them for 7 days. So those are 4 things definitely that Reddy would have wanted to keep the same. Question number 7. What was the control group? Well, I mentioned back up in question 3 that I was calling group 2 the control group, but I never said why. Well, let's answer that question right now. I am saying, come on, there it goes. I am saying that group 2 is the control group because the jars normally should be uncovered. And I'm going to emphasize that word normally. And I'm going to change it all to red here. Why am I emphasizing the word normally? Your control group is almost always the group that is treated normally. Normally, these jars should not have been covered. Ready had to do extra work to put cloth coverings on them. That's why that's the test group. His uncovered, group 2, would be the control. Finally, what was Ready's conclusion? I'm going to do a little extra work here because in class, of course, we've been writing CER conclusions, haven't we? I think we have. We have been doing these CER style conclusions, which stands for claim, evidence, reasoning. So I want to do a CER type conclusion. Oh, jumped down a little too far for me. I want to do a claim, evidence, reasoning type conclusion for Ready's experiment. Okay, so what was his claim? I think we can say that his claim was maggots are not spontaneously generated from meat. A nice complete sentence that sums up the findings of Ready's experiment. His uncovered group had maggots, his covered did not. So because both groups did not show maggots, he can claim maggots are not spontaneously generated from the meat. What was Ready's evidence to back up his claim, to support his claim? Well, the jars covered by cloth never contained maggots, while all of the uncovered jars had maggots. So that is pretty good evidence. If they were spontaneously generated, the maggots should have shown up in every jar, but they only appeared in the ones that were uncovered. So how are we going to link that evidence to our claim so people understand how the two are related? Well, we can go back to something that was in the description of the experiment. Maggots hatch from eggs laid by flies on the meat. Flies could not reach the meat in the covered jars, so no maggots appeared in them. Flies could only get to the uncovered meat, which explains why those jars had maggots. Flies could not get to the meat in the covered jars. They could not lay their eggs. No eggs, no maggots. This disproves the idea of spontaneous generation. I hope you found this example helpful and that you want to keep these notes and this example with you as your group works through some example problems. And again, a couple of those you're going to end up presenting to the class. Thank you.